Dear students, welcome to today's class. Today I am going to explain a very interesting topic, that is parametric point and parametric equations of the parabola. So what is the necessity of introduction of these parametric points and parametric equations is to simplify the equations of tangents, normals, point of contact, all those things. Okay. First of all, let us take one parabola, whatever may be the parabola. Let the equation of the parabola is y square is equal to 4ax. Here x and y are variables, x and y are variable, that means they can take any value. So in place of x and in place of y, in place of x, I will take x is equal to at square and y is equal to 2at, where t is a parameter. Here t is called a parameter. You can take any value in the t. For any value of t, this x comma y belongs to that parabola. Let us check it. In place of y, substitute 2at. So 2at whole square is equal to 4a into x means at square. So this is equal to 4a square t square is equal to 4a square t square. Is it true or false? Yes, it is true. That means for any value of t, if you substitute t is equal to 3, t is equal to 4, t is equal to root t, t is equal to 0 also you can substitute. X is equal to at square and y is equal to 2at. That means the point at square comma 2at lies on the parabola. This point is called parametric point and it is simply denoted as t. That means at square comma 2at. If you take a point like this at1 square comma 2at1, this is denoted as t1. If your point is at2 square comma 2at2, this is denoted as t2. Understand? T means at square comma 2at. T1 means at1 square comma 2at1. T2 means at2 square comma 2at2. So these points are called parametric points and these two equations are called parametric equations. Understand this. Now if the parabola is of the form, for example, if y square is equal to 4ax, then your parametric point is at square comma 2at. At square comma 2at. If your parabola equation is y square is equal to minus 4ax, y square is equal to minus 4ax, your parametric equation, parametric point is at square comma 2at. Okay now, let me substitute here. In place of x, substitute minus at square, in place of y substitute 2at, you will get the same answer. If your if parabola is x square is equal to 4ay, x square is equal to 4ay, then the parametric point is 2at comma at square. 2at comma at square. That means in place of y substitute 2at. So if you in place of y substitute at square and in place of x substitute 2at, you will get 4a square t square and 4a square t square. If your parabola equation is x square is equal to minus 4ay, so your equation of this is 2at comma minus at square. So in place of y, substitute minus at square. So therefore you will get 4a square t square is equal to 4 times a square t square. So these are the parametric points on the parabolas 1, 2, 3, 4. Understand different types of parabolas. So now in this video, I am going to explain all the formulas related to t. All the formulas, equation of the tangents, equation of the normals, conditions, all those things, point of contacts and point of intersections, all the points related to T, that is a parameter. So that's why you watch this video very carefully and note down all these points in a notebook. All T formulas will be on in a notebook. Okay. So I hope that you understand this concept. So let us continue the class. Welcome to this concept. So the concept is equation of tangent and equation of normal at a point T. At T means, always remember, at T means the point is at square comma 2at and the parabola is y square is equal to 4ax. The equation of the parabola is y square is equal to 4ax. Let there is a point that is at square comma 2at. Okay now. Now what is the equation of the tangent is at T, yt is equal to x plus at square. Yt is equal to x plus at square, where t is a parameter. Again, at the equation of the normal at the point T is y plus xt is equal to 2at plus at cube. So I will give the small proof for the equation of the tangent. How it came? Yt is equal to x plus at square. Okay. So let us take this s is equal to y square minus 4ax is equal to 0, of course. Now what is the equation of the tangent? S1 is equal to 0. So S1 means what? y1 minus 2a of x plus x1 is equal to 0. This is the equation of the tangent. Okay na? Right. What is your x1 y1? So your x1 y1 is x1 is at square. So this is a x1 and it is y1. Your x1 is at square and your y1 is 2at. So this is a y1, that is a y into y1 means 2at minus 2a into x plus x1 means how much? At square. This is equal to 0. Now simplify. You can cancel 2a, 2a. Since a is not equal to 0, you can cancel 2a. So therefore, this is equal to yt multiply inside minus x minus at square is equal to 0. Take these negative terms to right hand side. So this is equal to yt is equal to x plus at square. So this is the equation of the tangent at t. Yt is equal to x plus at square. And we can find out the equation of the normal also. Equation of the normal. If you want to find out the equation of the normal, so this is a equation in the linear form ax plus by plus c is equal to 0. And this is again we will write down bx minus ay plus k is equal to 0. If you want to find out that k, again you substitute this at square comma 2at, you will get this format, that is a y plus, that means, so I will explain here. So multiply with, this is a x plus, so multiply with the minus x minus yt plus at square is equal to 0. Now what is the equation of the normal? So here ax plus by plus c is equal to 0. Then what will be the equation of the normal? So the equation of the normal means t will come, 1 will go. So this is equal to tx plus y plus k is equal to 0. Tx plus y plus k is equal to 0. Tx, again 1 will go here, here minus is there, plus will come. So that is the equation of the normal. How to find out k value? Again the normal also passes through the point at square comma 2at. That means t into, in place of x, substitute at square plus y value is 2at plus k is equal to 0. Understand? From this, what is your k value? So your k value is given by minus, this is equal to at cube minus 2at. K value is minus at cube minus 2at. So almost you will get the answer, that is see here tx plus y. So this is a tx plus y. So this is a Tx plus y equation of the normal I am telling. Tx plus y. So this is a k value, for example, if it is plus k, this side is no, if you take to right hand side, so this will is equal to 280, otherwise you put it here 280 plus 80 cube. So this is the equation of the normal. The equation of the normal is Tx plus y, otherwise Tx or y plus xt is equal to 280 plus 80 cube. Okay now? So this is a brief proof of the equation of the tangent and the equation of the normal at the point t. T means 80 square comma 280. Okay now? I hope that you understand this concept. So let us go for next concept. Welcome to this concept. This concept is equation of the chord. We know that already definition of the chord is, it is a line segment joining any 2 points on the curve, the parabola, any 2 points joining, it is a line segment. This is called chord. Let P and Q be any points on the curve, the line segment joining PQ is called chord. Equation, the line segment joining PQ is called chord of that parabola. Let us take the parabola is y square is equal to 4ax. Let us take the parabola is y square is equal to 4ax. Let us take the 2 points as a P, a t1 square comma 2a t1 and a Q, a t2 square comma 2a t2. So this is denoted as t1 and this is denoted as t2. T1 and T2. Then the equation of the chord. The equation of the chord is, the formula is y times T1 plus T2 is equal to 2x plus 2a T1 T2. This can be simply solved. We can solve this equation by taking 2 point form. So this is x1 y1 and it is x2 y2. Then what is the equation of the line passing through the 2 points x1 y1 x2 y2 is y minus y1 is equal to y2 minus y1 by x2 minus x1 into x minus x1. Substitute here and you simplify, ultimately you will get the answer. So here y minus y1 means 2a t1, y2 minus y2, so that is a 2a t2 minus 2a t1 by x2 minus x2, that means a t2 square minus a t1 square is equal to x minus x1, x minus a t1 square. See here you can cancel here a cancel, here t2 square minus t1 square, so that means a square minus b square, a plus b into a minus b, t2 minus t1 minus t1 you can cancel here, t2 minus t1. Ultimately your next step is that is equal to a is cancelled, t2 so again 2 will remain in the denominator, t2 plus t1 will be there. In the numerator a is cancelled, only 2, here denominator t2 minus t1 will be cancelled, denominator t2 plus t1, so this is equal to x minus a t1 square. Then you cross multiply it, and you take to another side, you will get, so this as y times t1 plus t2, that is equal to minus 2a, multiply it this, if you multiply this, minus 2a t1 t2 minus 2a t1 t2 minus 2a t1 square minus 2a t1 square is equal to, you multiply here, so 2x minus 2a t1 square, 2x minus 2a t1 square, minus 2a t1 square minus 2a 2n square will get cancelled. So they take that value to right hand side. Ultimately you will get the equation of the chord, that is t1 plus t2 is equal to 2x plus 2a times t1 t2. So this is the brief proof of the equation of the chord. Okay, now you write all these points in a notebook, particularly those who are studying 11th class, those who are in the beginning of the 11th class, keep a separate notebook for one book for 200 pages weight long notebook. one book for parabola and one book for hyperbola, one book for ellipse, for all, each one book. All these proofs you write it in a book. So if you learn all concept using proof, you never forget. You never forget. Particularly those who are in the beginning of the 11th class. Those who are joining 11th class, you write down all these proofs, all the proofs in a particular notebook. So one book for one concept. Okay, right. So this is the proof of the equation of the chord joining the 2 points T1 and T2. So I hope that you understand this concept. So let us go for next concept. Now I am going to explain this concept. This is called focal chord condition. What is the focal chord condition? Means already we know that what is a focal chord. It is a chord passing through the focus. So this is a chord passing through the focus. It is called the focal chord, PQ. Let P and Q are the endpoints of the focal chord. Focal chord. Okay, now let P, the coordinates of P as AT1 square comma 2AT1, the coordinates of AT square comma 2AT2, AT square comma 2AT2. Okay, these are the endpoints of the focal chord. Okay, now we know that equation of the chord, just now we have seen that equation of the chord is, so this is the equation of the chord. Already equation of the chord or equation of the focal chord, both are same only. Okay, now, so the formula is y times T1 plus T2 is equal to 2x plus 2a times T1 T2. Okay, now, right. Now the thing is, since it is a focal chord, it passes through the point a comma 0. So of course, the equation of the parabola is y square is equal to 4x. Standard form we are taking. That means this parabola is passing through the point a comma 0, which are the coordinates of the focus. So in place of x, substitute a, in place of y, substitute 0. Let us see what happens. Since this focal chord is passing through the point a comma 0, let us substitute. In place of a, you substitute here 0 into T1 plus T2 is equal to 2 into x means how much? A plus 2a T1 T2. So this right hand side whole thing will become 0. This is also 2a also we can cancel here 1. Take to right hand side. So this is equal to T1 into T2 is equal to minus 1. So this is a condition, this is a relation between this T1 and T2. If P and Q are the endpoints of the focal chord, if T1 and T2 are the endpoints of the focal chord, not chord or not ordinary chord, that means the chord which passes through the focus, then the relation between T1 and T2 is equal to, is what is the relation between T1 and T2? T1 into T2 is equal to minus 1. Understand? So this is the proof. Very easy. Now, while solving the problem, if one end of the focal chord is given, we can guess the other end using this relation. From this relation, we can take T2 is equal to minus 1 by T1. T2 is equal to minus 1 by T1. In the second coordinate, that is Q, so what is Q here? A T2 square comma 2a T2. Now, wherever T2 is there, substitute minus 1 by T1. Substitute here. If you substitute here, what happens? A by T1 square minus 2a into T2 is equal to how much? Minus 1 by T1. So that is equal to minus 1 by T1. That's all. So we can generalize this. What is that? For a focal chord, if your point P is AT square comma 2AT, then the other end is A by T square comma minus 2A by T. If P is one end of the focal chord AT square comma 2AT, the other end of the focal chord is A by T square comma minus 2A by T. This is the proof for this. Okay. Particularly, you have to remember this. So T1 into T2 is equal to minus 1. So very nice concept. I hope that you understand this concept. So let us go for next concept. Welcome back to this concept. This concept is length of the focal chord. Length of the focal chord. So already we know the focal chord is a chord which passes through the focus. If you want, it's a line segment, therefore definitely it will have some length. Let the one end of the focal chord is at square comma 2at, automatically the other end will be a by t square comma minus 2a by t. So here onwards, if it is a focal chord, don't take that as a at1 square comma 2at2 and q is at2 square comma 2at2, t1, t2, don't take that. Why? Because already we have a relation that is t1 into t2 is equal to minus 1. So here there is only one parameter, that is t. If you take t1 and t2, there are two parameters will be there. Don't take like that. Okay, now? So there are the endpoints of this focal chord. If it is a focal chord only, then only this applies. If it is a general chord, you have to take t1, t2. Okay, now I want to find out the length of the focal chord, that is PQ. General formula only x1, y1, x2, y2. The distance between the 2 points formula, distance formula under square root of x2 minus a by t square minus at square, x2 minus x1 whole square plus y2, 2a by t minus 2at whole square. Okay, now, right. So if you simplify this, here a is there, here a square will take outside, here a you can take common, again a square, here also a will come a square, on the whole a square will come. So if it is come outside, actually modulus of a you have to write down, no need. Why? Because a is always a positive quantity. So this is equal to a into under square root of, so this is a 1 by t square minus t square whole square plus, here actually two minuses are there, two minus, you can take one minus, you can take a minus, you can write down both plus. Why? Because if you take minus common outside, minus 1 whole square it will become, again take 2 common outside, so if you 2 common outside means here 2 square is there, so 4 times 1 by t plus 1 by t plus here t will be there whole square, 1 by t plus t whole square. Right, you can simplify this. This is equal to a into under 1 by t square minus t square whole square. This is equal to a plus b whole square. A plus b whole square means a into a square, that is 1 by whole square, plus b square, that is b square, plus 2ab. 2ab. Of course, here previously 4 will be there. 2ab means 2 into 1 by t into 1 by t. Okay, now, right. If you simplify this, you will get this ultimate, your answer is t plus 1 by t whole square. So if you simplify this, so this is equal to a times under square root of 1 by t plus t whole square. Again, this is a is equal to 1 by t plus t. Check it here, check here. So whole to the power of 4 you will get, here you will square. 1 by t plus t whole to the power of 4 you will get, ultimately you will get a times t plus 1 by t whole square you will get. Let us check this calculation. So let us check this calculation. So you will get here, expand this is, if you expand this you will get like this, a into under square root of 1 by t to the power of 4 minus 2 plus t to the power of 4 plus, so this is 4 by t square plus 4t square plus 2s are 8. So if you simplify this, you will get 1 by t plus t whole to the power of 4. So that will be your final calculation. So what is the length of the focal chord is equal to a times 1 by t plus t whole square. Okay, now I hope that you understand this concept. Welcome back to this concept. The concept is number of normals from a point. How many normals we can draw to a parabola, right? Let us take the parabola y square is equal to 4ax. At the point t, let there be a tangent. At the tangent at the point T, let there be a normal. This is the normal. This is the normal at T. So we know the equation of the normal. Equation of the normal at T is given by the formula. Already we proved that y plus xt is equal to 2at plus at square. Yeah, y plus xt is equal to 2at plus at cube. Sorry, this is a at cube. Okay, now that is the equation of the normal. That is the normal red line. So let there be a point on this normal. So that is a x1 comma y1. Any point on the normal. Let us substitute here, since the normal passes through the point x1 comma y1, we have y1 plus x1t is equal to 2at plus at cube. Okay, now let us simplify this. Let us simplify it in an order. So this is written as, take this as a at cube plus 2at minus x1t minus y1 is equal to 0. So this is equal to at cube plus 2a minus x1 into t minus y1 is equal to 0. This is a cubic equation in T. It is a T cube. So T cube, of course, T square is not there. T cube, T, some constant. X1, Y1 is a constant. Why? Because we have taken a fixed point. That means, depending upon the value, sorry, whatever may be the value x1 and y1, whatever may be the value x1, y1, this equation has three roots. Three roots. This equation has three roots. These three roots may be real, may be imaginary, whatever may be that. That means, from this we can say what is there. If it is another tangent is there, from this we can draw one normal. If there is another tangent is there, we can draw another normal here. That means we can draw at most three normals from a point x1 comma y1. We can draw, since this equation has three roots, we can draw either one normal or two normal or at most three normal. So this is a cubic equation. It will have at most three roots. That's why we can draw at most three normals from a given point x1 comma y1 to a parabola, whatever may be the parabola. Okay, now I hope that you understand this concept. Let us go for next concept. Let us come back these results on normals. Okay, there are two results are there. So let us see these results. So if this is a tangent, the slope of the tangent m is equal to t, then the slope of the normal is equal to minus 1 by t. Why? Because the product of the slopes is equal to minus 1. That is minus 1 by t into t. So t will get cancelled, minus 1. The product of the slopes is equal to minus 1. Right. So here let us take two normals are there. One normal is at t1, another normal is at t2. Let they intersect at point some p. Therefore, the point of intersection of the normals at the points t1 and t2 is given by the formulas 2a plus a times, right. If this normals at t1 and t2, the point of intersection is equal to 2a plus a times t1 plus t2 square minus t1 t2, comma y coordinate is a times t1 t2 times t1 plus t2. Of course, here the equation of the parabola is y square is equal to 4ax. Okay, now I hope that you understand these two concepts. Let us see some more results on normals. Welcome to this concept. So very easy concept. So this is also comes under results on normals. Let us take that there is a normal at a t1 and there is another normal at a t2. Let these two normals are perpendicular to each other. That means the angle between these normals is 90 degrees. Then the result is t1 into t2 is equal to minus 1. t1 into t2 is equal to minus 1. So this is the result. So another result is at t1 there is a tangent, at t2 there is a normal, t2 normal, at t1 tangent, then these two are parallel. That means a tangent at t1 and a normal at t2 are parallel to each other. then the result is T1 into T2 is equal to minus 1. T1 into T2. Both are T1 into T2 minus 1 is. But observe here, both are normals perpendicular to each other. But here at T1 tangent, at T2 normal, but these two should be parallel. Tangent and normal, if it is there, there is no rule, such rule. If this tangent and normal are parallel, then the relation between T1 and T2 is T1 into T2 is equal to minus 1. Okay. I hope that you understand these two concepts. Let us go for next concept. Welcome back to these two results on normals. Very, very interesting results they are. Let us take T1 and at T2, there are two normals are there. So, these are the two normals. Let these two normals intersect on the parabola at T3. Okay, once again I am telling. So, at T1 and T2, there are two normals are there. If they intersect, there is no need to intersect. If they intersect on the parabola, that is at T3, then the relation between T1, T2, T3 is T1 into T2 is equal to 2. That is T1 into T2 is equal to 2 and T1 plus T2 is equal to minus T3. So, these are the results we will get using that parametric equation, that is a parameter, by taking T. So, T1 plus T2 is equal to minus T3. Okay, now. So, these are the two results that we got from this figure. Right. Coming to second one. Let at T there is a normal. So, that is a normal. If this normal makes, that means these are the points on the PQ. This is the normal PQ. If this line segment PQ, the line segment of the normal line segment, if it makes an angle 90 degrees, that is, if it is making an angle 90 degrees at the focus, yes, then T is equal to plus or minus 2. If it is making 90 degrees at the vertex A, then T is equal to plus or minus root 2. At the focus, if it is making 90 degrees, then T is equal to plus or minus 2. If it is making 90 degrees at the vertex A, then T is equal to plus or minus root 2. So, these are the two results that we have using normals from these diagrams. Okay, now, I hope that there are still some more topics are there on T, but these are very, very important for your JEE mains preparation. I hope that you enjoyed today's class with some more topics. In the tomorrow's class, I will present before you. Until then, all the best for your exams.